Hola, buenos días. Primero, agradecer vuestra participación en estas jornadas y específicamente
Well,
vuestra
first of all,
vuestra
thank you
asistencia
very
a
much for
esta
participating
pequeño
and
ratito en el que vamos
attending
a comentar bueno, pues unos
this meeting.
hallazgos en un
We're
estudio que
going to
hicimos
talk
sobre
about some of the
siniestralidad
breakthroughs in the field
de turbinas.
of
Pues primero, presentarme.
the
Mi nombre soy Pedro
incident
Soria,
rates in the field of
soy del área de
turbines.
ingeniería de
I am
MAPFRE
Pedro Soria. I
Global
come
Risk
from Global Risk
y casi toda mi carrera
MAPFRE
profesional pues la he
Engineering,
ejercido en el
and
área
I've been basically working
de
in the
análisis y
field
evaluación
of
de
the
riesgos,
risk
primero en INITSAMAP
assessment
y en los últimos años ya dentro de MAPFRE
in
Global Risk.
ITSMAP and then in MAPFRE
Dentro
Global
de
Risk.
lo que es
And
la siniestralidad dentro del
when
mundo del
talking
seguro, pues
about
no deja de ser pues, la
casualty
cara B,
rates
¿no?
or incident
del mundo del
rates,
seguro, que es para lo
we
cual,
are
para
sort
lo que
of
se
the
contratan los
phase
seguros, que es para
B
dar
of
cobertura en caso
insurances.
de
So this is
siniestro.
to
Tradicionalmente,
provide coverage
la
when there is
siniestralidad
an
pues, ha
incident.
existido la
Usually,
dicotomía entre
there is a
siniestralidad de
dichotomy
frecuencia, siniestros que
into
ocurren
the
pues, con
frequent
mucha
incidents that
frecuencia y
happen
normalmente
very
baja intensidad, y
often
luego la
and
siniestralidad
the
de
low
intensidad,
frequency ones,
que
and
son
then the
siniestros pues, de un
intensity
gran volumen
incidents,
y
which
que
are high
afortunadamente
volume
pues, ocurren
incidents,
pues,
but
muy
they
de vez en
do
cuando, ¿no? En
happen like
términos
from time to
cualitativos.
time, not
Pero con
very
las turbinas,
often.
pues,
And in the field of
pues, bueno, pues,
turbines,
¿qué se da? Pues que cuando ya
what
tienes cierta
happens
cartera
whenever you have
de empresas
quite
de
a
generación eléctrica con
portfolio
riesgos en todo
of
el mundo, pues se
utilities all
convierte
over the
en un
world,
riesgo en el cual
then this
tenemos
turns into a
siniestros
risk
de
where we
intensidad
have both
con cierta
intensity
frecuencia, ¿no? Con lo cual,
and
pues entendimos que
frequency
era un punto importante
incidents.
en el cual pues,
So
debíamos
this is why we
investigar
thought
y
this
tratar
was an interesting
de traer conclusiones no solo
subject to
para
tackle,
digestión interna en la
to
parte de
digest
verificación, es decir,
this
qué es lo que vamos a
ourselves,
ver, qué
so to
recomendaciones
know what are the
podemos dar a nuestros
recommendations that
clientes,
we can
sino también,
provide to our
lógicamente,
customers,
tener pues,
to
mejores
also
criterios
in order
para
to
la
improve
suscripción y
our
cotización
criteria to
de los riesgos.
underwrite
Además de ello, pues el poder
an
compartir
insurance
pues, con los agentes, ¿no,
policy,
del
and
mercado,
also to
operadores,
talk to our
tecnólogos,
clients, and then also to
ingenierías,
share our knowledge
mantenedores,
with the
etcétera, pues las
engineers, with the
conclusiones en que
maintenance
entre todos pues,
people,
consigamos
with
que
people
el riesgo
experts
de
in
la avería mecánica,
technology,
en este caso
so that we
de
all
las
become
turbinas,
aware
pues
that
suponga un
the
menor coste en
risk
general pues,
of this
para todos,
kind
¿no?
of
Para
incidents,
el comité de
especially
asegurados,
with the
para las entidades
turbines,
aseguradoras
will
y
mean a lower
finalmente
risk
pues,
for all
para
of us,
el
for the
producto que
insurance
están
company,
vendiendo, pues, que
and
sea pues, más
also for
competitivo y
the
menor
makers
coste
of these
para
companies, so
el
that they
ciudadano.
can produce something which is
Bien, pues
more
vamos
competitive in terms of
ver,
cost
este
and
sería pues un
safer
guión de
for
lo que sería
the
la charla, y luego
citizens.
una
So this
introducción,
is the
me vais a
guideline
permitir los
of
que os dediquéis
my
profesionalmente a esto, pues
presentation,
vamos a recordar,
and there's a
vamos a hablar de
brief
una serie de
introduction that
conceptos
I'm going
sobre
to
turbinas
make
y
to
tecnologías de
talk
generación
briefly
que a los
about
leemos que algo con la
generation
materia o que hace
technologies
tiempo que no lo ven, pues le
and
refresquen
about
pues las
turbines
ideas y
to sort
conceptos
of
principales
fresh up
que
some of the
ayuden a
main
entender
ideas and
luego
concepts
los
that will
resultados
help
y las
you
conclusiones que
later
sacamos del
on
estudio
to
de
understand the
siniestralidad.
results and
Vamos
the
a ver sobre
conclusions
qué
that we've
muestra
been
de estudio
drawing from our
hemos trabajado, en
survey.
cuántas
So
centrales,
we've
cuánto
been
volumen de generación, durante cuánto tiempo.
seeing the volume of
Bien, vamos a
generation,
ver
for
qué
how long
información
it
analizamos de los
happens.
siniestros,
So
cuántos
let's see what's the
siniestros,
information
etcétera.
we
Y
analyze
por
when we
último, pues ya
analyze
vamos
an
a ver
incident,
los
what kind
resultados,
of
¿no? Los
incident,
resultados
and then we'll
reales que
talk
se
about
dan unas
results.
cifras, pues que
And then
veremos,
we'll
pero que
give
siempre
you
las
some
tenemos que mirar pues,
figures,
con
and
cierta
then these
distancia porque
figures we
no
also
deja de
have
ser
to look
una
at them
muestra,
from
¿no?
some
Pero
distance because
que
these
tratamos ya
they
en el
are
último apartado de
only a
conclusiones,
sample. And
pues
then
cuando los
there
números
is
son
the
pues
conclusions.
patentes
And then in the
sus valores,
conclusions,
bueno, pues
there is
ya
when we
pues
have
tenemos un
values
indicio de que
and we
hay
can sort of draw
puntos donde
conclusions
podamos
because we've got
trabajar.
sort of an indicator that we can
Empezamos
work
con
to
la
improve the situation.
introducción, ¿qué es una turbina?
So let's
En este
talk
caso
about
vamos a hablar
what
de
a
turbinas
turbine is.
térmicas,
We're
es decir,
going
no
to talk
hablamos de turbinas
about
hidráulicas,
thermal
y son
turbines, not about
específicamente también
hydraulic
para la
turbines, and they're
función de generación
specific
de
to
energía
produce
eléctrica. Estas turbinas son térmicas
electricity.
porque aprovechan la energía de
And
un
they
fluido,
use the
tanto
energy
su
of a
temperatura
fluid,
como su
its
presión
temperature and
para
its
accionar
pressure
un
to
eje.
activate a shaft
Básicamente los dos
or a
principales
rotor.
como turbinas, pues tendríamos la
We've
turbina de
got
gas,
the gas
que no es
turbines.
que estemos quemando gas,
We're
podemos
not
quemar,
burning
normalmente se quema
gas.
gas natural,
Usually
pero también
you
podemos
burn
quemar otros
natural
combustibles
gas, but
líquidos
we
y en
might
gas nos
also
referimos
use
a
other
los gases de
liquid
combustión, que son
fuels.
los que tienen
When we
las
say
temperaturas
BAS, these are
y la
combustion
presión para
gases which
activar el
have the
equipo. Y
right
luego la
pressure
turbina
and
de vapor,
a
en
temperature
el cual
to
lo que tenemos
activate
es
the
vapor
equipment. And then we've
de agua
got
pues a muy
steam
altas
turbines.
presiones. La turbina de vapor pues
This is a steam
pues ya
turbine,
tienen pues
and
120, 130 años
we're talking
de
about
existencia. Es un equipo
quite
pues, muy,
old pieces of
pues,
equipment. They
mucha,
date back
con
from
mucha
100,
experiencia
120 years ago. And here we basically make use of the steam pressure. We are going to deal with very high pressures, and these equipments are going to be very solid and robust, and we're going to work with a high thermal inertia. And we're talking about steam. So the thing is, since it is steam, it might turn into a liquid element. And this is the main issue with turbines. Very fine equipment. As soon as we deal with liquid elements, we might have some breakdowns, some failures, as we will later on see. So let's talk about the yield of these turbines. This is highly related to temperature, input and output temperatures. So in the future, the trend when producing these steam turbines to make that more efficient, we used to work until recently with a critical temperature, and then we used to reheat the steam. But lately, we've been developing new technology that will no longer allow this to happen, but we're rather working with some 700 degrees centigrade and 350 bars. So these are the future, these new turbines. So then we've got steam turbines. This steam is generated with some heat source, and in these sort of burning chambers, what I do is I obtain my air by means of a compressor, then I inject this fuel, and I add heat to this combustion, and this is how I get gas with temperature and pressure, and this is how I can activate the shaft. So temperature is fundamental for the yield, for the efficiency of the turbine, and we have an energy generation equipment, and this is thanks to the increase of the input temperature into the turbine. I'm talking about 1400 degrees of temperature. And this happens in the first round of blades in a turbine. So we've been increasing the materials and also the cooling systems for these blades, so we can work with a very high efficiency. And these turbines, they don't work on their own, of course. They need an installation to be located at, and there we've got thermal plants, conventional ones, where you usually produce steam with from a fossil fuel, and basically it is coal due to its price. Then we might also have thermal plants with open cycle. I'll have this turbine activating driver, and then I've got the exhaust gases that I will use in a combined cycle, and then as a source of heat we might be using renewable energies, and in our area mainly this is the biomass plants, so we use renewable fuels and also solar thermoelectrical plants. So this is a thermal conventional plant. You see the turbine in the image. This is just a small part of a big installation. In this kind of power plants, which have been running for a long time, we usually have also storage areas, and also to treat and store the coal, and that requires some volume. I've got huge boilers, and when I burn coal, there are many impurities impurities. So this is why I request having some areas to filter these impurities, and also, according to law, things are more and more demanding in the field of emissions, and we've got to also treat emissions. So the yield is some 40%, and we might end up having some problems because this is large equipment, and sometimes there are shifts in the regime. So to start this kind of cycle, it requests some hours or even a day to start up these kind of old power plants. So this is why they request long-term horizons. But they are very reliable. On the other hand, they are very reliable. The yield is about 98%, and then it depends also the price of the incoming fuel and the outcoming energy. It might be more or less profitable. Then we've got gas turbine, open cycle. This is very simple. When only equipment, you've got the combustion chamber, you've got the generator, and that's it. Basically, the yields are similar, but the fuel you need has to be of higher quality and then more expensive as well. This is why in the field of generation, they are used basically for islands or for some consumption peaks. That sort of payback for the higher price. Then we've got these open cycle gas turbines, so we are exhausting hot gas. We are also producing steam, so we obtain energy thanks to the combustion, and we also obtain energy thanks to the steam turbine. The steam might obtain half the power we obtain with the gas turbine, and the combined yield is of some 60%. So it is highly competitive because even though the fuel is more expensive, we end up with a high yield. And also, they're very simple in design, and the running is very easy for this kind of equipment. So then we have cogeneration. This is any kind of technology where the residual heat due to exhaust gases or other gases might be used for either community uses or for industrial uses. And then we've got renewables, and we've got biomass, so we've got waste from agriculture or forestry, and from some of the pig feces and so on. Then we got different kinds of cylinders, as you see there. Some are like a parabol, and we use this energy to heat up a fluid. Usually it is steam, and from there we produce electricity. These kind of solar installations are usually big in volume, and they request a high investment. And then we've got the premium tariffs, and then the price of the fuel, which is zero because it is an energy in some of these cases, or some other sort of renewable free energies.
Covered the background information regarding turbines, so now let's get into further details. Here we have a sample broken down by technologies, and we're talking about most of the turbines being concentrated in the fossil fuel thermal power plants. Then we have the open cycle and the renewable power plants. In the lower part of the slide, you can see the ratio of loss of profit as a result of damage. In the case of renewable power plants, we can see that the cost is pretty high, but it's small if we compare it with the investment cost. In the other technologies, we're talking about similar levels. The total insured sum is 669 billion euros per year. So 65% of the Spanish GDP, which is quite a considerable sum. As for the number of plants, we're talking about 2,000 medium-sized plants operating during a 6-month period. So here we have a sample broken down by regions. Most of the sample is located in Western Europe, as you can see. We also have small samples from Asia, Australia, Eastern Europe, Latin America, and the Middle East. And here we can see large variations in the ratio of loss of benefit in relation to the insured sum in damages. The loss of revenue is very significant in case of an outage or failure that lasts for months. You need to consider that the cost of our electricity market is very, very high. So this triggers the cost of claims. In Latin America, we're talking about 32%, whereas in Western Europe, we're talking about 10%. Ratio. Regarding our turbines, who manufactures our turbines? Well, we have the gas turbines that account for 1/3 of the total turbines in the switchboard, and we only have 3 providers that provide us with 80% of the turbines that are in the market, and that has its pros and its cons as well. So we're talking about only 3 main suppliers, and as a result of a recent merger, we're really talking about 2. The good part is that there's less competition. Well, that's the bad part, sorry. And the good part is that it's easier to find spares. As for steam turbines that account for 2/3 of the total installed capacity, the 3 first suppliers account for only 30% of the turbines in the market. And it's also interesting to see this distribution by age. There you have the distribution of turbines by age, and 50% of the gas turbines have an age above 10 years. So there you have the curves. Most of the gas turbines are pretty recent, and there's a great availability of spare parts. And the regulation systems in place allow for this age. As for the steam turbines, the regulation systems of the time in which the turbines were put into place are very, very different to the current ones. We see the substantial growth also in combined cycle power plants in recent years. So, as for incidents, we selected a sample of incidents. We analyzed a total of 79 incidents for a detailed analysis, and these 79 incidents account for 627 million euros. We're talking about a gross figure. So based on the information of our experts and based on the inspection report, we analyzed each of these incidents. We analyzed the administrative information, the time of occurrence, the location, technical characteristics, seniority, circumstances of the event, information regarding the causes, the damages, type of repairs. So we analyzed all those elements in order to understand the specificities of each incident. All incidents differ from each other, so it's very important that you have a clear idea of what happened in order to adopt the necessary measures as a result. Here are the conclusions of this study. Here we have a distribution of the incidents based on the sum of money. And we know that 20% of the population holds 80% of the resources. Here we have the distribution of the incidents. 25% of the incidents account for 75% of damages. The most important one was this one here, the first point that I'm pointing to in this curve, so that 20% of the events are events that account for 10 or more million euros, 40% account for 7 million euros or more, and 60% 1 million euros or more. There you have the distribution based on the sums involved. And here we have a comparative graph that compares gas turbines with steam turbines. The gas turbines, there you have the number of events registered, so we have more events in the case of gas turbines than steam turbines. The total sums of material damage is higher for gas turbines as well than steam turbines. As for the loss of benefit, we see that steam turbines take the lead. As you can see, the column is considerably higher. As for the combined sum, total combined sum, the figures are more balanced out. And last, average material damage is higher for gas turbines than in steam turbines. And the total combined average, we see that the steam turbines account for greater sums of money. Here we have the analysis of the origin of the failure. We analyze why it failed, what piece of equipment failed that led to the event. We see that the main element that caused the event was the blades. Blades account for 40% of the events. As for other causes, well, some are unknown. Rim rivets, bearings, tightness systems, and many of them are below the 10%, as you can see. As for steam turbines, we can see that the causes are more distributed. The governor valves account for most of the failures and the events, and 20% of the sum. The blades are also to be blamed. The housing, rotor, lubrication, bearings. As you can see, there's a greater distribution. This is the origin of each event. And now, if we analyze the total causes from a holistic point of view, here you have a grouping of causes. Material failure accounts for 1/3 of the events and 50% of the damage volume. And then we have different kinds of errors: maintenance errors, operations errors, design errors, installation and assembly. So there you have the distribution of events broken down by causes. There's another element worth considering, which is that of the circumstances surrounding each event. In prevention and safety and engineering, we always talk about the need to be able to prevent this kind of situation. And we see that many times what happens is that after maintenance work, we see that 13% of the events take place right after the maintenance. That's something that needs to be considered. If we analyze the remaining circumstances, after maintenance, that accounts for 20% of the events. Truth is that the total cost is much, much higher. And as you can see, also many of the events are discovered during maintenance, and others are due to external causes. Some of the equipment that fail are under a warranty. And there you have the bars that illustrate the number of events insured or covered. And some of the causes have to do with the normal aging. But that's the root cause in a very limited number of events. If we consider both the number of events and the insured sums, we can compare the incident rate in turbines to the insured sum of the power plants. And there you have the total accident rate. You can see that in the case of renewable energy power plants, the incident rate is very, very high. And then we have the open cycle gas turbine power plants, followed by the combined cycle thermal plants. And last, we have the fossil fuel thermal power plant. And this includes both biomass and solar plants. Then we will listen to experts in operations and in technology that can help us understand these figures. But you need to understand that having a heat source that you control is much more reliable than having renewable energies that are more volatile or more technologically complex, like burning vegetable waste. Perhaps it's a matter of culture. And we have new stakeholders that have joined the market and that are operating these renewable energy power plants and don't have the experience of other plant managers in conventional sectors. What main conclusions can we draw based on this study of incident rate in turbines? Very important that we understand how, to what extent blades are often at the origin of the problems that we have in gas turbines. These are a very, very common cause. In the case of the conventional power plants, we see that there are many hand or manual operations, and as a result, the turbines become more sensitive to liquid water. And mistakes in operation can lead to damages and failures. Regarding revisions or checks allow us to identify problems at an initial stage. This entails lower costs. But, of course, things aren't being done well if a significant number of events occur at a very early stage. So that would be an important area for improvement. And we have the mistakes, human error in operations, And then we have, of course, aging, wear or fretting, etc. As for technology, the conventional thermal power plants are behaving relatively well. The level of performance is very high, and I've already referred to the level of performance of the generation plants that use renewable energies. Unless the major conclusion would be that we are all very much aware of the high incident rates in turbines. Everybody working in this sector is aware of this. And we see that the percentage or the degree of machinery failures far too high. And we can also conclude that there's a great variability depending on the markets. And depending on the specificities of the market, well, an event can have small or very significant consequences. And sometimes we see that an operator with high levels of profitability is forced to shut down for minor events, and sometimes they consider not shutting it down precisely because of the potential loss of income. Another conclusion would be that it's very important to have a solid relationship with a technology expert. This is like marriage. When you marry, you need to trust and work with the other party. And here it's very, very important that we work hand in hand with the technology providers, with the technology experts that tell us how we need to maintain our equipment. In case of events or incidents, it's very important to work hand in hand with the technology experts to solve the problem as soon as possible. And of course, we need to acquire broader knowledge of all these problems, not only regarding the engineering aspects. We need to understand what elements need to be controlled further. And of course, it's very important that we understand the underwriting aspect as well. That's all on my side. I hope you have found my presentation interesting. Thanks for your attention, and if you have any comments or questions, please feel free to take the floor.
¿Alguna pregunta o algo?
Questions? I've covered a great amount of information regarding Spain, but I also represented the situation in other European countries. We based our study on EON and EDF data as well. Can you draw conclusions at a regional or geographic level regarding incident rate? Well, there's a lack of balance if we compare the different countries in our portfolio. We do have some numbers and figures, but we believe that perhaps they don't allow for adequate benchmarking. If the electricity market price is high, well, that will have a huge impact because it costs much more money to shut down a plant in order to carry out maintenance. So everything depends on the cost of power, the cost of electricity. That is what governs many decisions. And then we have the situation of countries where there is a scarcity of water. That is also a factor that affects to a great extent. Good morning. Have you identified in your study a series of measures or best practices that in case they had been implemented could have decreased the amount of damages. Well, the market is what it is. And it's very important that we analyze the cost of security. And my presentation is very much linked to what other panelists are going to expand on later on. It's very important that we know what is being done to address the indicators and have everything duly controlled. Each event is different. It's a matter of screwing, tightening a screw. If you don't do it appropriately, it can destroy a gas turbine. So even very minor things can have a great impact. Then we have other more complicated issues such as thermal treatment. So there's a wide array of circumstances and factors that need to be considered. As part of your statistics, have you considered fires? Well, compared with machinery failures, fires are almost negligible. So you don't have a specific indicator for fires? Yes, we do have fire risk, but we don't have a sample that would allow us to conduct such a detailed study as the one that we have done for machinery failures. Well, you don't have further questions. I'm going to give the floor to Alejandro García Gasco and the panelists so that